Hello everyone and welcome. Let's model, assemble, and animate a Schmidt coupling with a Fusion 360. So what is a Schmidt coupling? Imagine a situation where you have a shaft, here in light gray, rotating, and you want to transmit that rotation to another shaft, the driven shaft, here. But the axes are not aligned with each other. They might be off here in the x-axis and the z-axis. And that's where the Schmidt coupling assists you to transmit that rotation. For the modeling, we'll just need 5 parts. The dark gray part here, that I'll call it the hub, the light gray, the shaft, the green one, the outer disc, the red, the link, and then the yellow one, the inner disc. Okay, so let's start modeling. I will start with a sketch on the front plane. Take the line command, go upwards 56 millimeters here, and take the slot command, center to center slot, take these 2 points, give that a dimension of 24. Okay, draw one circle here with 18, then make a 2-point rectangle, place that here, take that midpoint constraint, take that endpoint and that line, dimension the length with 44, and make that bottom line tangent to that arc. With X, I make that construction geometry, that one as well. And that's it for our first sketch. I exit that. I'll go into the extrude, take that bottom rectangle, make that a symmetric whole length 22 dimension, and I'll create a new component. I OK that. Make that sketch visible again. Continue with the extrude. This time adding, joining to our base here. Give that a symmetric overall length of 12. Okay, so we got our first component. We can apply a little chamfer to those edges here with 2 millimeters. And I'll call that hub. I can hide that sketch for a moment. There's our first component. And I'll apply some appearances to our design here. So I go into Fusion Appearances, go to Paint. Then to Glossy. And I'll take that gray here and place the other ones I want. My design, the gray, green, the red, and that yellow one. I close that. Now for our next component, I make that sketch visible again. Go to extrude. Take that circular region here, again as a new component. Make a symmetric whole length distance of 44. Now this one I will call shaft and apply that light gray appearance. I can hide that sketch. Close the appearance tab and I'll rotate that a little and start with that sketch for the discs. So I go to the sketch command, take that face here. With P, I project that circle. Take the line command, go up here with the distance 48. Apply a vertical constraint to that. Make that construction geometry. Take the circle command, give that a distance dimension of 22 millimeters. Then continue with the line from that origin down here. Apply an equal constraint between those two here. Make that construction geometry and apply an angular dimension of 120. I'll rotate that a little here. Then another circle here with an equal constraint to that one. One more circle here with a 12. Make that solid line and take the 3-point arc between here and there. Again, solid line. Apply tangency between those sketch entities here, down there as well. And radial dimension of 44. Okay, there's our sketch. Move that over here, there. And then I will make a circular pattern of those 3 sketch entities with this as its center point 3 times. I OK that. And that's it for that sketch. I finished that. Once more, they extrude. Take those regions here. Again, symmetric overall, 6 millimeter for a new component. Okay, that. Sketch visible again. Then these circles here with a symmetric overall 22. 22. Hey. That's what I want. 22. Joining to this disc here. Okay, we got our third component. I will rename that. And that is the inner disk because it has these two pins, right? Inner disk. Like that. Sketch. And I will apply yellow appearance to that one. And now I want to make a copy of this inner disk to create the outer disk. And I want this to be independent because I want to modify it. And one way of doing this is with a boundary fill. So you take that, you just select the body at hand. The operation is a new component. And you need to select a cell, and there's only this one here. And, okay, it's right on top of the other one. Here. And that will be our outer disk. So let's rename that outer disk. And now with move, I'll pull that out over there. And okay, actually, this is the outer disk here. This is the inner disk. Okay. And now I will remove these pins, or first I can apply some color to that. Green. Yeah. And let's take that move command again, but this time for faces. And so I will just take these three faces here and go to translate from point to point. And I'll just take that point right here and pick the other one that's on that face. And there it is, our outer disk. Now let's model our last component, the link. I take that face, project that edge, draw one line, 62 millimeters long. Make that construction geometry. Sketch a circle here in the end. Make that equal to that other one. Go into the slot command, center to center slot. Take these two centers. Okay. And then make those two, that arc and that one, equal. And now extrude that region, and let's just define that with a distance to object, and just take that face. Well, we want a new component. That's it. Rename that link. And give that some nice red color. Now let's assemble our group here. First, we'll establish that misalignment. So let me just hide those parts. So we got here that hub and the shaft, the driving shaft. And let's move a component, that hub, creating a copy, and go to the translate, and let's just say we want to place it somewhere here to the right. I said create a copy, okay. So let's take 96 millimeters to the right, then 48 millimeters upwards, and then 66 to the back. Okay, so that is the situation. We got hub number 1. Let's ground that. We got here hub number 2. Again, grounded. And then we see that shaft that is not positioned yet. So let's press J for joints and go into the revolute here and take that central connector and place that here in the center as well. If you have trouble picking the right one, you can press Control on your keyboard, and then you get the 3 visible joints and you take the center one. Okay. Let's make a copy of that shaft. Copy and paste. There it is. And apply again a revolute joint between that one and that one. Let's make that outer disc visible. Here it is. Let's place that there with the rigid constraint between that outer disc and that shaft. Okay. Let's make a copy of that one. And apply that one again with a rigid joint between that edge here and that one. And let's flip the component. Okay, there's that. Let's make that link visible. And well, I can hide here, that is the driving shaft and that is the driven shaft. So I will hide these 3 to make things more visible. And apply a joint, a revolute joint between that edge and that one. Okay then. Then again, create some copies here. One more copy. Okay, drop that somewhere. and apply the next joint here. Yeah. Third one here. Okay, so we got these three. And, well, we could just make that inner disc visible and apply the revolute joints between these. So take that edge, take that one, okay, that, take that one, and that one, yeah, and that one, and that one. No, I wasn't in the command. So, there, we got that. Okay. Now let's make that hub, that shaft, and that outer disc of the driven shaft visible, and create some more copies of our links. No. There. Just one more. Okay. So maybe I will hide the inner disk for a moment, and those three initial links. Yeah, that one and that one. And that outer disk, that first one. And work on those joints here. So I take the revolute joint again. Oops. And that edge and that one. Then that edge and that one. And that one here. Okay. We do need the inner disc now to attach that to those three. Let's move those components to get them close here. With a revolute joint, I connect these two here. And now let's see. I need to move that one down there. I'll just ground this for a moment and get those two here into position. Unground that one. And apply the next one here, those two. Okay. And the last one between those two here, J, there. Okay, now let's have a look from the front. Let's make that first outer disk visible, those three links. So all components are visible. And let's take that first revolute joint, which is the one that binds that driving shaft to our hub. Make a right mouse button click and go to Animate Joint Relationship. And there you see the mechanics of the Schmidt coupling. The transmission of the driving shaft is transmitted over the system of inner and outer discs and links to the driven shaft. I hope you like that, and I see you in the next video.